let us understand what is the equivalent resistance of two resistors connected in parallel with the help of following activity. Make a parallel combination of two resistors having resistances R1 and R2 respectively. Connect it to a battery, a switch, and an ammeter, as shown. Also connect a voltmeter in parallel with the combination of resistors. Switch on the circuit. And note the ammeter reading. Here the current, I, is equal to 5 amperes. Also take the voltmeter reading. It gives the potential difference, V, across the combination of resistors. The potential difference across the combination is 6 volts, which is equal to the battery voltage. Now connect the ammeter in series with resistor R1. Note down the current flowing through it. Let it be I1. Here, I1 is equal to 3 amperes. Similarly, measure the current, I2, through R2. Here, I2 is equal to 2 amperes. Sum of I1 and I2 is equal to 3 amperes, plus 2 amperes, is equal to 5 amperes. This is equal to I. Hence, I is equal to I1 plus I2. Suppose the equivalent resistance of this parallel combination is Rp. Then by applying Ohm's law to the whole circuit, we get I is equal to V upon Rp. Since the potential difference, V, across both the parallel resistors, is the same. Therefore, by applying Ohm's law to the individual resistors, we get I1 is equal to V upon R1. And I2 is equal to V upon R2. Now, substituting the values of I1, and I2 in equation 1, we get V upon Rp is equal to V upon R1 plus V upon R2. Therefore, V upon Rp is equal to V into bracket 1 upon R1 plus 1 upon R2. Cancelling V from both sides, we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Thus, if two resistors, R1 and R2, are connected in parallel, then their equivalent resistance, Rp, is given by the formula 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Hence, we conclude that the reciprocal of the equivalent resistance of a number of resistors connected in parallel is equal to the sum of the reciprocals of all the individual resistances.